Okay, here we go with example 1 on page 157. This is going to ask us to graph a linear inequality and shade it, graph another one and shade it, and then look for where the shading intersects. And that, again, is going to be where the solutions lie. Okay, let's go ahead and start here. We're going to, first of all, make this look like we can graph it. So we need to solve, in this one right here, solve for y. Now, go ahead and solve for y. Pause the video and solve for y. Go ahead and do that actually on both of these. Solve for y here and solve for y here. Pretend like they are equal signs. Okay, so what I got when I pretended like these were equal signs is I got, on the first one I got y equals x minus 1, and then the second one I got y equals negative half x, negative 1/2 x plus half. Now, there's going to be some fractions in this one, but it's not too bad, so I think we'll be okay in this one. Go ahead and let's graph these together. So when you graph the first one, you're going to have a point at -1, because that's the y-intercept, and then you're going to be going, here again is the slope, 1 over 1, so you're going to go up 1 over 1. So when you graph it, you're going to see that it looks like this. It goes up 1 over 1, and it's going to be a little bit like this. Now you do have to check as you graph it here. Think about, do we need to have a dashed line or a solid line? We'll go back here, and inequality 1s, this to me looks like indicates a solid line. All right, now we got to do the shading by testing. So we're going to test the origin. The origin, it's 0, 0. So let's put a 0 here for the x, and let's put a 0 for the y. We're going to ask ourselves, is 0 minus 0, or 0, greater than or equal to -1? And the answer on that one, of course, is yes. So we know that's yes. So what we're going to have to do is we're going to have to take our pencil and we're going to shade the stuff in where the origin is. So I'm just going to shade it like this. Now, if you're really neat, you might make it look a little closer to that. So it should look a little bit like this. On the second one, this is going to be a dashed line. And we've got to start by doing our intersection at the y-axis, which is going to be half. So it's about right there. Don't worry too much about detail on this one. Then what we have to do is from that half, this is a little tricky, we have to sink one hole, or drop one hole, and run 2. So I think that puts us about right here. Okay, so we started at a half. From that half, we put our pencil there, we drop a hole, which is a half and a half, and we run 2. Now what we're going to do is we're going to put a dashed line at, actually where these points run. So I'm going to put a line here and extend it out a little bit, and then I've got to put some dashes in here. If you're doing this with a ruler, it's a little faster. So you got your dashes there. Now we've got to determine, is the origin test going to work? Now you can see this thing rises a little bit above the origin. So we can use the origin test. We're going to go and put a 0 where the x is. We're going to put a 0 where the y is. So it's 0 plus 2 times 0, which is 0, less than 1. Now that is going to be a true statement. So since that's true, with the dashed line, we've got to do everything that is below the dashed line because the origin's right here. So when we did this, here's what we found out. There's a double shaded part, and it's right in here. All this stuff right here is double shaded. So we're saying that anything in this double shaded part right here is going to be a solution for both of the original equations, this one and this one.